we'll be looking at the laws of indices. So the very first one we want to look at here says if I have a raised to the power of m times a raised to the power of n, that is the same as a raised to the power of m plus n. Now you must understand this fact that before you can add the powers of two numbers, you must note that the numbers must be the same. Like this is a raised to the power m and a raised to the power n. So because they have the same base, let's call it that. So the powers can be added. If I have a raised to the power m multiplied by b raised to the power n, I cannot do this. So I cannot say this is equal to a raised to the power m plus n, because this is b and this is a. They are not the same. So the only time you can add their powers is when they are the same. Let's look at one or two examples of this. If I have 3 raised to the power of 2 to multiply 3 raised to the power of 3. So this, since they are the same numbers and their powers are different, even if they are the same, you can do that. I have 3 raised to the power of 2 plus 3, and that will give me 3 raised to the power of 5. Because the base are the same, 3 and 3, so I can add the powers. Let's look at one more example. If I have 2 raised to the power 5 to multiply 2 raised to the power 7. This is also simple because I have the same base, so I add the common base, which is 2. Then I add the powers, 5 plus 7, and that gives me 2 raised to the power of 12. So if you have the same power, the same base, you add the powers once they are multiplying. How about if they are dividing? Let's look at that. If I have a raised to the power of m divided by a raised to the power of n, just like what we did here when we were multiplying, we added the powers. So since we are dividing here, we subtract, so it becomes a raised to the power of m minus n. You subtract the powers. So put this in mind, the base must be the same. That is the only time you can subtract the powers, when you are dividing. So let's look at one or two examples of these two. If I have 5 raised to the power of 7 divided by 5 raised to the power of 3, this is the same as, since they have the same base, I can call this 5 raised to the power of 7 minus 3. Why? Because I'm dividing, and that equals 5 raised to the power of 4. How about if I have 12 raised to the power of 9 divided by 12 raised to the power of minus 2. So I want to do this. Since they have the same base, it's going to be 12, then 9. Division means I'm supposed to subtract, and there is a minus 2. So that becomes 12 raised to the power of 9. Minus times minus is a plus, so I have plus 2. So 12 raised to the power of 11. So I have just done that. So all these, you should put in mind that when dividing, you subtract. And please note that the base must be the same, then you subtract the powers when dividing. But if it is addition, then that means you are multiplying, and the base must also be the same for you to add the powers. The outer law of indices that we'll be looking at, so this was the first two. Let's look at the next ones. The next one here tells me that, so I call that the third law, tells me that if I have a raised to the power of 0, that is equals 1. So anytime you have any number at all and the power is raised to 0, is equals 1. So even if it's 5 million, it still equals 1. So if I have 12 raised to power 0 is still 1. Even if I have minus 3 all raised to the power of 0, that still equals 1. So put this in mind that when you have anything at all, any number raised to the power of 0, that equals 1. Another law we look at here simply says that if I have a negative power, look at that, a raised to the power of minus m is a negative power. When you have a negative power for your base, that simply equals 1 divided by a raised to the power of m. 1 over a raised to the power of m. You can see this. I want to change this negative power to positive, so it becomes a denominator, or I simply say I find the reciprocal. So 1 over whatever I've added here, but the sign changes. This simply also means that if I have a raised to power m, it can be also written as 1 over a raised to power minus m. So any power I have at all, I can change it. I can change the sign to positive or negative. All I simply need to do is find the reciprocal. So if I have 3 raised to the power of minus 2, that is the same as 1 over 3 raised to power 2, and that is the same thing as 1 divided by 3 raised to power 2 is 3 times 3, and that gives me 9. So this is called negative power. So we have negative, you can change it to positive, and even if you have a negative, a positive, you can change it to negative. Let's look at another example or another law of indices. All these examples or all these indices or all these laws, we will use them in some examples. So please just keep looking at them, keep studying them. We've looked at when you added, when you need to subtract, when you have a zero power, and when you have a negative power. So we want to look at other ones. What about when we have a fractional power? So our power is a fraction. How can we do that? So if we have a fractional power, say I have, okay, this is number 5, fine, a raised to the power of 1 over m. Now you can see this. The power is now a fraction. The power here is a fraction. Once you have a fractional power, this simply means that you have a root. So you write your root, the base goes into the root. Now the denominator of the fraction determines what root, the nth root, so we put m here, and the numerator of the fraction determines the whole power, 1. So it's easy. That can give me, or can give birth to another, which is a raised to the power of n divided by m. Look at that. So still the same approach. Since it's a fractional power, this means that I can have a root. So I have my root, I put the base there. The denominator determines the nth root, I put that there, and the numerator determines the final power. So all this raised to power n. So let's look at 1 or 2 examples of this, then solve. What about if I have 27 raised to the power of 2 over 3? 27 to the power of 2 over 3. Okay, we said once we have a fractional power, it means it's a root. So I have a root. The base is 27, it goes into that root. Fine. Then the denominator determines the nth root. I write that here. All raised to the power of the numerator, which is 2. So this equals 27 cube root of 27. That means which number will multiply itself 3 times. That's what it means by cube root. Which number multiplies itself 3 times to give me 27? So let me just write that somewhere here. 2 times 2 times 2, that is 8. So it is not 2. Then let's pick 3. 3 times 3 times 3, that is 27. So that means what we need is 3. So the cube root of 27 is 3. 3 multiplies itself 3 times to give me 27. So cube root of 27 equals 3. Then there's a power here which equals 2. So 3 raised to power 2 equals 9. That's one example of solving that. Let's look at one more. Let me write that somewhere here. This just one example. Let me write another one here. Say I have 16 raised to the power of minus 3 over 4. Look at this. I have 16 raised to the power of minus 3 over 4. Here I'm going to be dealing with 2 laws. A negative power and a fractional power. So let's pick it one after the other. What can we do here? First, let's change the negative power to positive. So how do we do that? We said we can change negative to positive. Don't forget, we'll find the reciprocal. Fine. 1 over, then we write out that 16 raised to the power of 3 over 4. So it becomes a positive power. And this simply means, once this stays there, 1 divided by, now there's a fractional power. This fractional power simply means that it's a root. Good. A root of 16. Fine. Then the denominator determines this. Good. All raised to the power of 3. So I have done this. And that simply means 1 divided by, the question now is which number multiplied itself 4 times to give you 16? Which number multiplied itself 4 times to give you 16? Okay, you might have to be thinking about that. Is it 3? Is it 7? Is it 12? And so on. You need to know a lot of this. You play with them, and that will help you well to get more of these things. So, which number multiplied itself 4 times to give you 16? Let's try that. Here we wrote 2 times 2 times 2 to give us 8. What about if we add another 2? 2 times 2, 4 times 2, 8 times 2, 16. So, in this case, we would have add 16. That means the number that multiplied itself 4 times to give us 16 is 2. So, we have 2 raised to the power of 3. And that means we have 1 divided by 2 cube. 2 cube means 2 times 2 times 2. And that gives me 8. So, you see that here we actually combined 2 laws of indices, a negative and a fractional. So it's possible we combine 5, 6, and even all the laws together. It doesn't matter. So this is just one of the laws again, fractional. Let's look at one more of the laws of indices. Here we have another law of indices that we're about looking at. So this is number 6. If I have a raised to the power of m, all multiplied by a power of says n, this is the same as a raised to the power of m multiplied by just n, and that can be written as a raised to the power of m times n. So any of this, you can still look at this here. A raised to the power of m multiplies or raised to the power of n. So that simply means you multiply the 2 powers, and that means m times n. So let's look at 2 examples on this. What about if I were given 25 raised to the power of half, all raised to the power of 2? This simply means 25 raised to the power of half times 2. And do not forget this is 2 over 1. So 2 takes care of 2. So I'm left with 25. 1 times 1, 1. So we have 25 raised by 1, and that is 25. So look at this. We have only multiplied the powers because they are working together. Okay. Let's pick another one whereby we combine virtually everything we've done so far. Here we want to look at 81 raised to the power of minus 3 over 4 times, oh, no, that shouldn't be times. I want to all by 2. So this means 81 raised to the power of minus 3 over 4 multiplied by 2, isn't it? Good. So 2 here 1 and 2 in 4 gives me 2. So I have 81 raised to the power of minus 3 over 2. So this is a negative power, and it's also fractional, and we understand what that means. This is the same as 1 divided by 81 raised to the power of 3 over 2. Now we have changed the negative power to positive only by finding the reciprocal, and we've done that. 1 over whatever we've been given. The only difference is the power changes sign. Now this is 81 raised to the power of 3 over 2. This simply means 1 divided by, now we say when we have a fractional power, that is simply a root. So we write 81 here, fine. The denominator determines that we're supposed to put a 2 here, but we don't write 2. If it's 2, we don't write. We only know that it is 2 there. So all raised to the power of 3. And that is the same as 1 divided by square root of 81. Which number multiplies itself 2 times to give you 81? 9. Thank you. So we have 9 raised to the power 3. And that eventually becomes 1 divided by 9 times 9, 81. 81 times 9, 729. So the whole of this question, which is 81 raised to the power of minus 3 over 4, all squared equals 1 over 729. This is just an example when you have multiple power. You can see m multiplies n. So it's called multiple power. A raised to the power of m, all raised to the power of n. Just multiply them and you have your answer waiting for you. Let's look at one more law of indices, then we'll round it up for the laws of indices so that we can pick a lot of examples solving and simplifying indices. In this case, we want to look at just the last one. When I have A multiplied by B all raised to the power of m. A multiplied by B all raised to the power of m. This is the same as A raised to the power m times B raised to the power m. A raised to the power m times B raised to the power m. So you can write this. In some cases you can split it. So let's look at one or two examples. If I have 2 multiplied by 3 all raised to the power of 2, this is the same as 2 squared times 3 squared. 2 squared times 3 squared, and that equals 2 squared is 4 times 3 squared 9, that is 3 times 3, and 4 times 9 equals 36. You can confirm that here. 2 times 3 is 6, 6 squared is still 36. You can see that. So in some cases, when the powers are the same, you can just decide to bring them back here, or when you have them this way, you can decide to expatiate them this way. So this is an example of another law of indices that we can use. We will begin to apply each of them as we move on with our jobs.